start in 1 minute. Today we'll be in section 6.5. The first part has to do with solving polynomial equations by factoring. Okay, a tautological definition. A polynomial equation is an equation that contains a polynomial. A quadratic equation in the variable x can be written in the standard form, ax squared plus bx plus c equals 0, where a, b, and c are constant real numbers, and the coefficient of x squared is not 0. So that is a does not equal 0. To solve polynomial equations, we're going to use the zero product property. So this property simply says if you multiply a times b and get a product of 0, then the two possibilities are a is equal to 0 or b is equal to 0. Possibly both are equal to 0. Well, we're going to apply the zero product property to solve polynomial equations. The method of applying the zero product property to solve polynomial equations is also referred to as solving equations by factoring. Okay, so we'll solve a number of equations by factoring. Well, if we're going to solve by factoring, we first want one of the sides to be equal to 0. So the first step here is to add 12 to both sides. So we get 2x to the second minus 11x plus 12 equals 0. Then we want to find the factors of the trinomial on the left-hand side. And if we can find the factors, we can find the solutions to the equation. So when we factor 2x squared minus 11x plus 12, we note that the greatest common factor is 1. So we'll try the AC method. 2 times 12 is 24. And we want to find two integers that have a product of positive 24 and a sum of negative 11. Okay, so it doesn't take too long to find that negative 3 and negative 8 are the two integers that we need. So over here, I'll transform the trinomial into a quadrinomial. And we write 2x squared minus 3x minus 8x plus 12 Out of the first two terms, we factor out the greatest common factor, which is x. And the binomial is 2x minus 3. The middle operator of subtraction, we bring that down. And then out of the third and fourth terms, the greatest common factor is 4. So we factor negative 4 out. Negative 8x divided by negative 4 is 2x. 12 divided by negative 4 is negative 3. And then the complete factorization of that trinomial is 2x minus 3 times x minus 4. Okay, we use the two factors in the equation, so we replace the trinomial with the two factors. 2x minus 3 times x minus 4 equals 0. Okay, now we're going to apply the zero product property to find the solutions. When it says to solve an equation, it means we want to find what are called the solutions. In this equation, where the variable x is involved, the solutions are the x values that make the equation true. So we're going to use the zero product property to find all of the solutions. If 2x minus 3 times x minus 4 gives us a product that's equal to 0, then to find the solutions, we set the factors equal to 0. So one of the factors is 2x minus 3. We set that equal to 0. The other factor is x minus 4. We set that equal to 0. We solve each of those two linear equations, and the solutions to those two linear equations are the solutions to the quadratic equation. So 2x minus 3 is 0. Add 3 to both sides. 2x equals 3. And divide both sides by 2, we get x equals 3 halves. And the other equation, we just add 4 to both sides, so we get x equals 4. Okay, the equation has two solutions, x equals 3 halves and x equals 4. If you ever have to use the set bracket notation, then you could list the solutions using the set brackets with the solutions inside the brackets, separated by a comma. Okay, let's move on to the next equation. 5x squared plus 7y plus 2 is equal to 0. Well, one side is already 0, so we want to factor the left-hand side. The greatest common factor is 1. So we proceed with the AC method. So here we multiply 5 times 2, and we get 10. And two integers that have a product of 10 and a sum of 7 are 5 and 2. Okay, so let's factor the trinomial. Transform it to a quadrinomial. We get 5y to the second plus 5y plus 2y plus 2. So here we're just doing the work on the side. If you want to include equals 0 in every step, you can. But I'm just factoring the trinomial, and then after I find the factors, I'll write the product of the two factors equals 0. Okay, then we factor by grouping. Out of the first two terms, the greatest common factor is 5y, and the binomial is y plus 1. The middle operator is addition, so we bring down the addition. And then out of the third and fourth terms, the greatest common factor is 2. The binomial is y plus 1. And so the factorization is y plus 1 times 5y plus 2. Okay, so now let's write the factors y plus 1 times 5y plus 2 with a product of 0. And now we apply the 0 product property. One of the factors is y plus 1, so one of the solutions will be determined by this equation, y plus 1 is equal to 0. The other factor, 5y plus 2, the second solution will be determined by solving this equation, 5y plus 2 equals 0. If y plus 1 is 0, then y is equal to -1. That's one of the solutions. And if 5y plus 2 is 0, first we subtract 2 from both sides. 5y is equal to -2. And then divide both sides by 5. Y is equal to -2/5. So the two solutions in set bracket notation, -1 comma -2/5. Okay, I'll turn you loose for a couple of minutes on the next one, part C. Solve this equation, x to the third plus x to the second equals 20x. Take a couple of minutes, and if you find the solutions, you can type them in. Hey, what did you come up with? If we're going to solve by factoring, we first want one side of the equation to be 0. So we'll subtract 20x from both sides. And we get x to the third plus x squared minus 20x equals 0. And then we're going to factor the left-hand side. The greatest common factor is x, so we have to factor x out. And when we factor x out, we get x times x to the second plus x minus 20 equals 0. Now we want to see if we can factor the trinomial x to the second plus x minus 20. Let's look at that over here by itself. Just the trinomial, x squared plus x minus 20. Note the greatest common factor is 1. So the AC method, we multiply 1 times negative 20, which is negative 20. And two integers that have a product of negative 20 and a sum of positive 1 are 5 and negative 4. Okay, so that guarantees that we can factor this. So transform the trinomial into a quadrinomial. So I'll do it by writing x squared minus 4x plus 5x, and then minus 20. And then factor by grouping. Out of the first two terms, we factor out x, and the binomial x minus 4 stays behind. The middle operator is addition, so we bring down addition. Out of 5x minus 20, the greatest common factor is 5. Factor 5 out, and the binomial is x minus 4. So our factorization of the trinomial is x minus 4 times x plus 5. Okay, over here we'll write the factored polynomial and set it equal to 0. So we have x times x minus 4 times x plus 5 equals 0. Okay, the solutions will be found by setting each of the factors equal to 0 and then solving for x. One of the factors is just x. It's a factor, so we set it equal to 0, x equals 0. Okay, there's nothing more to do there. X equals 0 is one of the solutions. The next factor is x minus 4, so we set that equal to 0. X minus 4 is 0. Add 4 to both sides. And a second solution is x equals 4. Then the third factor, x plus 5, set that equal to 0. And then solve for x, we subtract 5, and we get x equals negative 5. Okay, that equation, that polynomial equation, has 3 solutions, 0, 4, and negative 5. Okay, notice that the solutions don't have the variable in them. It's just the numbers. You can always verify that you have the right solutions by substituting the variable with a solution. Okay, let's move on to the next page. Okay, so we've practiced solving equations by factoring, but here's a step-by-step procedure for what we did. The procedure for solving equations by factoring is as follows. Make one side of the equation equal to 0, then factor the other side. In step 3, set each factor equal to 0 and solve the resulting simpler equations. And then in step 4, the solutions found in step 3 are the solutions to the first equation. Okay, let's do some more. Solve this equation by factoring. 12m to the second plus 28m equals -8. Well, we want one side to be 0, so we'll add 8 to both sides, and we'll get 12m to the second plus 28m plus 8 equals 0. Okay, now we want to factor the left-hand side. The greatest common factor is 4. So we can factor 4 out, and we get 4 times 3m to the second plus 7m plus 2 equals 0. So we have this numerical factor 4. And since we have an equation and 4 is non-zero, we are free to divide both sides by 4 so that we don't have to bother with that factor of 4 anymore. So that's one of the key differences between factoring a polynomial and solving an equation by factoring. Since we're solving an equation, we can divide every term on both sides by the same non-zero number just to get rid of the clutter that it gives us. Okay, so I'll go ahead and do that here. We'll divide both sides of this equation by the factor 4, and we'll just be left with 3m to the second plus 7m plus 2 equals 0, because 0 divided by 4 is 0. Okay, now let's factor the left-hand side. We can use the AC method again. 3 times 2 is 6. And 2 integers that have a product of 6 and a sum of 7 are 1 and 6. 1 times 6 is 6, and 1 plus 6 is 7. Okay, so if we transform the trinomial into a quadrinomial, we get 3m to the second plus 1m plus 6m plus 2. Then factor by grouping. Out of the first 2 terms, the greatest common factor is m, and the binomial is 3m plus 1. Bring down the middle operator of addition. And out of the third and fourth terms, the greatest common factor is 2. and the binomial is 3m plus 1. Then this trinomial's factors are 3m plus 1 times m plus 2. Okay, so over here in the equation, replace the trinomial with the two factors, 3m plus 1 and m plus 2. And the product is 0. Now we apply the zero product property. Since the product of the two factors is 0, to find the solutions, we set each of the factors equal to 0. So 3m plus 1, we set that equal to 0. The other factor, m plus 2, set that equal to 0. So on the left, we subtract 1. 3m is equal to negative 1. And then divide both sides by 3. We get m equals negative 1/3. And the other factor, m plus 2, is equal to 0. Subtract 2, we get m equals negative 2. Okay, so the solutions in set bracket notation are left set bracket negative 1/3, comma, negative 2, and then right set bracket. Okay, let's try the next one. The binomial 2w minus 7 quantity squared equals 0. So take a few seconds and solve that equation. And type in the answer. Oh, what did you come up with?
W equals 7/2.
Yeah, w equals 7/2. This one, we have the binomial 2w minus 7 squared. So it's already factored for us. Uh, 2w minus 7 squared, it means 2w minus 7 times 2w minus 7. So if we set each factor equal to 0, 2w minus 7, 0, 2w minus 7 is 0. Add 7 and divide both sides by 2, we get w equals 7/2. Well, if the two solutions are the same, there's just one solution. We don't need to write 7/2, comma 7/2, because it's the same number. But we can say that w equals 7/2 is the solution with multiplicity 2. So I'll write that here. The solution is w equals 7/2 with multiplicity 2. The 2 is the number of times the factor appears in the factorization. Okay, the next example, we have r times the binomial 11r plus 4 equals 0. Take a few seconds and find the solutions. So hopefully it will take just a few seconds. What did you come up with?
R equals 0 and R equals negative 4/11.
That's right. Okay, I got negative 4/11 online, but there's another solution. We have an equation. The right-hand side is 0, and the left-hand side is factored. One of the factors is R. So we set each of the factors equal to 0. R is equal to 0, and then 11R plus 4 equals 0. Okay. R equals 0 is one of the solutions. And then to find the second solution, first subtract 4 from both sides. So 11R is equal to negative 4. And then divide both sides by 11, we get R equals negative 4/11. So make sure that you don't overlook the fact that 0 is one of the solutions. Okay, so the solutions are 0 and negative 4/11 if you use the set bracket notation. Okay, the next example, t plus 2 times t minus 5 equals 0. So you can tell me pretty much by looking what the solutions are in fewer than 10 seconds. So what are the solutions?
Negative 2 and 5.
Yeah, t equals negative 2 and t equals 5. So this equation, the right-hand side is 0 and the left-hand side is already factored. So we set each factor equal to 0. T plus 2 is 0 and t minus 5 is 0. If t plus 2 is 0, then t is equal to negative 2. And if t minus 5 is 0, t equals 5. Okay, so the two solutions are negative 2 and 5 for t, for the variable t. Okay, on the next page, we'll solve the following equations by factoring. The first one, 9m to the third plus 33m to the second plus 18m equals 0. Hey, take a minute or two and find the solutions.
Excuse me.
All done. First, let's answer this question. How many solutions are there?
3.
Yep, there are 3 solutions. Okay, I got one answer online. Let's go through the process. One side is already 0, so we'll factor the left-hand side. The greatest common factor of all 3 terms is 3m. And after we factor 3m out, we are left with 3m to the second plus 11m plus 6 equals 0. Okay, so let's see if we can factor the trinomial. So over here, let's look at the trinomial by itself. 3m squared plus 11m plus 6. Use the AC method. 3 times 6 is 18. 2 integers that have a product of 18 and a sum of positive 11 are 2 and 9. 2 times 9 is 18, and 2 plus 9 is 11. Okay, then we transform the trinomial into a quadrinomial. So I'll write it as 3m to the second plus 2m plus 9m plus 6. Out of the first 2 terms, factor out m. And the binomial 3m plus 2 stays behind. The middle operator in the quadrinomial is addition. And then out of the third and fourth terms, we factor out 3. And we get 3m plus 2. And then our complete factorization is of the trinomial is 3m plus 2 times m plus 3. Okay, over here in the equation, we write the 3 factors, 3m times 3m plus 2 times m plus 3. The product is 0. So this time when we apply the 0 product property, we set each of the 3 factors equal to 0. 3m is 0, 3m plus 2 is 0, and m plus 3 is 0. If 3 times m is 0, divide both sides by 3. 0 divided by 3 is still 0, so m equals 0 is one of the solutions. The next equation, 3m plus 2 is 0. We subtract 2 and divide by 3. We get m equals negative 2/3. And then the third equation, m plus 3 is 0. Subtract 3 and we get m equals negative 3. Okay, so the three solutions are 0, -2/3, and -3. Okay, the next one, 16y equals 9y to the third. I'll let you work on that one for about a minute. Okay, let's get started on this one. In order to solve by factoring, we want one side to be 0. So I'll begin by subtracting 9y to the third from both sides. So we get 16y minus 9y to the third equals 0. And then factor the greatest common factor out. The greatest common factor is y. So we get y times 16 minus 9y to the second equals 0. Inside the parentheses, we have 16 minus 9y to the second. So there's a term for that kind of polynomial. One of our terms, well, it's a difference. It's a difference of squares. So over here, I'll remind you how to factor a difference of two squares, a squared minus b squared. One factor is a minus b, and the other one is a plus b. Okay, if you want to write it so that it's more familiarly a difference of squares, you can replace 16 with 4 to the second. And 9y to the second is the same as squaring the term 3y. So our complete factorization is y times 4 minus 3y times 4 plus 3y. And the product is 0. Okay, then set each factor equal to 0. Set y equal to 0. Set 4 minus 3y equal to 0. And set 4 plus 3y equal to 0. So 0, we're already done with that one. Y equals 0 is one of the solutions. On this one, we can add 3y to both sides and then divide both sides by 3. We get y equals 4/3. On this one, we can subtract 4 from both sides. So we get 3y equals -4, and then divide both sides by 3, we get y equals -4/3. Okay, the three solutions in set bracket notation, 0, -4/3, and +4/3. So once again, we utilize the difference of squares factoring formula to help us factor the polynomial. Okay, let's look at the next one. 10n to the second minus 4n equals 6n to the third. For convenience, what I would do is I would subtract 10n to the second from both sides and add 4n to both sides so that I get 0 equals 6n to the third minus 10n to the second plus 4n. And if you would rather have the equal 0 on the right-hand side, you are free to do that if you want. Okay, but now that we have one side equal to 0, we factor the other side. The greatest common factor is 2n. So 0 equals 2n times a trinomial, which will be 3n to the second minus 5n plus 2. And then the trinomial. So over here, let's look at the trinomial by itself. 3n to the second minus 5n plus 2. Apply the AC method. 3 times 2 is +6. Two integers that have a product of +6 and a sum of -5 are -3 and -2. So we transform the trinomial into a quadrinomial, 3n to the second minus 3n minus 2n plus 2. And factor by grouping. Out of the first two terms, factor out 3n. The binomial is n minus 1. Bring down the middle operator of subtraction and factor out -2. And the other factor is n minus 1. So the factorization, n minus 1 times 3n minus 2. So over here we have 0 equals 2n times n minus 1 times 3n minus 2. Okay, set each factor equal to 0. 2n is equal to 0. N minus 1 is 0. 3n minus 2 is 0. If 2n equals 0, divide both sides by 2. One of the solutions is n equals 0. If n minus 1 is 0, we add 1 and we get n equals 1. For 3n minus 2 equals 0, first add 2 to both sides and then divide both sides by 3. We get n equals 2/3. So 3 solutions. Let's get started on the next one. So on this one, I would add 9 to both sides. So we get 0 equals 81c to the second plus 54c plus 9. The greatest common factor of all three terms is just 9. So we have 0 equals 9 times 9c to the second plus 6c plus 1. Since we're solving an equation, we can divide both sides by 9 just to get rid of the clutter that's in the way, if you want. Not required, but If we do so, we get 0 equals 9c to the second plus 6c plus 1. We factored this yesterday. If you remember, this is a perfect square trinomial. The two factors are 3c plus 1 and 3c plus 1. So there's one solution with multiplicity 2. C equals 1/3. Okay, we're out of time. Go ahead and sign in for attendance.